Okay, so after the study of the air intake, the next component to study in an aircraft engine, this is the compressor. Here, I will not make such a large difference between the booster, the low pressure compressor, the intermediate pressure compressor, the high pressure compressor, or the fan. I will speak about the compressor. In fact, you will see that I'm mainly speaking about multi-stage. So, most probably not too much about fan of a civil transport aircraft, but maybe about the fan of a military fighter that can have 3 or 4 stages, okay? And my main objective is to understand where is the steady state line compared to the surge line. So this is, in fact, trying to understand on the compressor map. So I'm speaking in reduced variables. I indicate here the pressure ratio. It can be of the fan, the low pressure compressor, intermediate pressure compressor, high pressure compressor. So I mean here I'm speaking about a system that is at a given rotational speed. It can be at N1, it can be at N2, it can be at N3, depending on the type of engine you have. And in function of the mass flow rate corrected. Corrected, it also indicates the entrance condition related to N. So if it's N1, it will be square root TT1 divided by PT1. If this is the intermediate pressure compressor, this will be T entrance of the intermediate compressor divided by PT entrance, etc., etc. And it will be in function of different, let's say, rotational speed that are also expressed in N corrected. So it can be N1 divided by the square root TT1. It can be N2 divided by the square root TT entrance. This is not 1.5. So the entrance condition related to the index of the rotational speed that you are considering for this compressor. And each compressor has a, let's say, surge line. So this surge line is coming from aerodynamic considerations that we will explain more in details in this part of the course. And what I would like to understand is where is the steady state line that we have discussed before compared to this surge line. We know that it is related with the ISO TT3 divided by TT1 line. This is related to TT3 divided by TT1. And this steady state line is not unique. The steady state line is depending on the Mach number, the flight Mach number, and we will have, let's say, a line that will be something like this, with different values joining a single one at a certain moment when you have saturation of something. We have explained it can be the saturation of the exhaust nozzle, it can be the saturation of the low pressure turbine, depending on what you are considering. If this is the high pressure compressor, it will be saturation of the low pressure turbine. If this is the low pressure compressor, it will be the saturation of the nozzle. And this is depending on the Mach number that is increasing in this direction. And I'm interested in what, in fact? What is the, let's say, final objective of what I will explain here? This is to understand what is this distance. The distance, the margin, you could say, the safety margin, the safety distance that you have between the steady state line, I've not indicated the steady state line, with the surge line. You see that this distance is changing with m dot. You see that in the example that I took, this distance is changing with m dot. So this is at m dot corrected 1, this is at m dot corrected 2, and you see that this distance is changing. This distance, you see, it's not the pressure ratio, it's something else. It is this value compared to this one, it is this value compared to this one. So this will be, in fact, this distance is equal to P, C of the compressor on the surge line minus PC on the steady state line that you consider at the value m dot corrected, let's say I, because it will change. And I will in fact not take this distance, but I will take this distance divided by another value of the pressure ratio, because a difference of pressure ratios, this is also a pressure ratio, and I will take this divided by the pressure ratio at the level of the steady state line. That is also at a given value, at the same value of the mass flow rate corrected. And this is what I will call the surge margin. That is expressed, as you can see, in percent. Okay? And so so this is a definition, let's say. You could have maybe defined that in another way, but it looks like something quite normal. And what is my objective? My objective will be to understand what is the reason of the shape of the surge line. What is this exactly? From where is it coming? What are the considerations to be taken to understand this surge line? Surge line of a multi-stage compressor. So 2 stages, 3 stages, 8 stages, 10 stages, I don't know. And also to understand why is this existing? Because we say, there is a margin. Everybody can understand that there is a margin. So the steady state line must be under the position of the surge line. But what is this value? Is it 1%? Is it 10%? Is it 20%, 25%? Why is this value not very small? Because if you look at, let's say, existing engines, of course it will be difficult to have this, except if you do simulations yourself with a very good understanding and knowledge of the engine. You will never find a compressor map, so a low pressure compressor map, an intermediate compressor map, a high pressure compressor map showing the steady state line. And of course, I must be very clear, there are, if you have a 3-spool engine, a Rolls-Royce Trent, with 3 different rotational speed, you will have 3 different surge margins at each working point of the engine. Why? Because you have a surge margin in the, let's say, low pressure compressor map, in the intermediate pressure compressor map, and in the high pressure compressor map. Of course, each time only one of them, but you have 3 maps. For each map you have a surge line, and you position the steady state line, the same steady state line, compared to each of the surge lines. So you have 3 surge margins. That means that you could have a surge in the LPC and not here and not here, or there and not here and not there, or there and not here and not there, I don't know. Or maybe a surge here and there and not here, I don't know. But it's important to understand why are they not saying 1%? Because it's very bad, this surge margin. Because surge margin means you could go to the surge line and you decide to put it at a lower position. So you decrease your performance. Why? Why can that be 25%? It looks like you are putting this line, down. Why? Why are you decreasing your performance. And that will be the two things that I will try to understand in the study of, let's say, compressors. This is not again to explain the velocity triangles in compressors. It's not again to explain the compressor map. No, I know this. This is to understand what is exactly this surge line, from where is it coming, what is influencing the position of this surge line, and also to understand in a second step, second question, what is the reason of the fact that the surge margin is not extremely small, but can even become extremely large? What leads the manufacturer to decrease its performance? Of course, the name is in the question. It's a margin compared to what? Compared to the surge line. That means a dangerous phenomenon. So this margin, we call that the surge margin. You could maybe also call that a safety margin, because it will be a safety compared to the surge line. So, in order to understand first, the first question is, what is this surge line? We need to look a little bit to the situation into more details. And look at the details. Make a zoom on the surge line. And in fact, you could see that the surge line, this is very often something that was most probably like this originally. And then they extended the zone of the surge by a zone that is called a rotating stall region. And the surge line is now this one. So there is a zone near the surge line where they accept to have a kind of intermediate phenomenon that we call the rotating stall, and that extends, that is allowed by the manufacturer in order to have, let's say, a bit higher positioned surge line. Okay? And it's interesting to note that if you look to, I don't know how many compressors, you will always see that this zone where you have, let's say, an extension of the working domain of the compressor is located at low rotational speeds. Not there. It's not there that you will allow to extend that. What is a low rotational speed? We can certainly discuss that. Maybe it's going up to there, but it's not in this region. It's not at the regions of, let's say, the 100% rotational speed. Okay? The rotational speed is very often indicated in percentage compared to not so much a maximum. I would not speak about the maximum, but more a nominal. So they define a nominal rotational speed, very often corresponding with the rotational speed at takeoff rating, maybe a bit lower